This video is on the objective compute and interpret the coefficient of determination, or R squared. And this is the second video on this objective. I'm hoping you watched the first one. It was about half an hour long. It was a bit longer because I showed you, very quick ways to find R squared, the longer roundabout way on your calculator to find R squared, and it was a pretty long video. This one will be a lot shorter. I'm just going to go right into it and calculate R squared. I'll do it in two different ways. One where I do a quick calculation with the formulas, and another where I just have your calculator spit out R squared for you. And if you remember how to find the correlation coefficient R, right, this coefficient of determination is simply that squared, R squared. Right? Okay. All right, I got the calculator up. Right. So here, if you want to see more about the topic, click on More Instruction. Look at their videos, their notes, their examples. Hopefully those help you. All right, so a new mine opened, and the number of dump truck loads of material removed was recorded. The table below shows the number of dump truck loads of material removed and the number of days since the mine opened. So we have days since opening. We'll call this our independent variable x. The number of dump truck loads, material taken out of the mine on that day, we'll call these the output, the dependent variable y. Now, we don't have to do a lot here. It says a least squares regression line was found, right? They found some best fitting line. Using technology, it was determined that the total sum of squares, right, the SST, was 2,349. And the sum of squares of the errors, SSE, was 329. Use these values to calculate the coefficient of determination. Remember that R squared. And round your answer to 3 decimal places. Well, remember there were a couple formulas for this. Had these written up last time, and I had this picture up. This time, I'll just call it, last time it was for lift strength and time. Let's just call it x and y. We had sum of squares of the regression, the sum of squares of the errors, the sum of the squares total, and SST is going to be equal to SSR plus SSE. And I drew this whole thing up last time. But the thing we're looking for, this coefficient of determination, R squared, is the proportion of SSR to SST. You take SSR divided by SST. Or if you replace SSR with SST minus SSE, you get this formula, 1 minus SSE over SST. And this is the information they gave us, right? They gave us SSE and SST, so I'll use this formula to calculate R squared. So that's the quick way to do these, right? They give you most of the information already, so I do 1 minus, and they told us, the sum of the squares of error, the SSE, was 329, and that divided by the sum of the squares total, the total sum of squares, SST, was 2,349. And that gives me 0.8599. They're asking us to round to 3 decimal places, so 0.86. So this one here, R squared, the coefficient of determination. And what this means is that 86% of the variation in y can be explained by the linear regression. So that the linear regression model is probably going to be a good model here. But in order to really say that, we need to look at the scatter plot, all right, and see if a linear model seems like a reasonable model for our data. Now, this one's obviously not it. All right, remember, the value of R squared cannot be less than 0, and it can't be greater than 1. So automatically, I have a 50-50 chance. All right, so that's one way to do it. Now, the other way was actually entering the data, right? And I'm actually going to look at a scatter plot here too. All right, I'm going to look at a scatter plot and look at the best fit line and all that. All right. So let me go to my tables, stat, edit, and then down list L1, I'll put these, days since opening, my X coordinates. And then down list L2, I'm going to put the number of dump truck loads, the Y coordinates, and I'll be back when I have all these 5 pairs of data listed. Alright, I'm back, and you see all 5 of those pairs of data listed, and then I'm going to make a scatter plot. Alright, second, stat plot, maybe plot 1, turn it on, make sure it's the first type, a scatter plot. My X list is L1, my Y coordinate list is L2, great. Now I'm going to hit zoom, go number 9 for zoom stat, and there's my scatter plot. All right, these 5 points. Looks like a line would be a good fit. These are tending upward. Looks like there's a nice positive relationship. Now, if you looked at just these 4 points, it looks maybe more like a downwards curving parabola would be better. But this point out here maybe makes me think it tends more to be linear. And there's only 5 points here. You can't really say a lot with 5 points, but just looking at the scatter plot right now, I feel like there's a reasonably strong linear relationship between these. Okay, and then let's do that best fit line. Right, so remember, you get out of here, go stat. Well, in fact, before I even do this, before I get the best fit line, actually, I would like the calculator to give me r squared. The r squared is 0.86. Right? You can have the calculator just give you r squared without using any formulas or whatnot. Now this is after you've entered these lists, so it would be a lot quicker to just use the formulas because they gave you all the values you need. But if I entered those lists and I want to have the calculator just find this r and r squared for me, got to make sure the diagnostics are on, and I've done this in other videos as well. But go second, go to the catalog, hit the X inverse button to go down to the D's, right? And then scroll down until you get to diagnostic on. All right, hit enter, enter again, and now once these are on, and you perform the linear regression, find the equation for the best fit line, it'll also give you r and r squared, right? It'll give you the coefficient of correlation, r, and this coefficient of determination, which is just r squared. So let's do that. Hit the stat button, go over to calc. Number 4 is linear regression. L1 is X list, L2 is Y list, calculate. And you see it gives you the slope, 3.73, the y-intercept of the best fit line, 36.21, and here it is, r squared, 0.860. 0.860. Amazing. All right. Now it didn't come out exactly, because I'm sure they rounded these SSE and SST numbers. And because those are rounded, that's why my number earlier wasn't exactly like this number. This is more accurate. All right, but this r squared is what we're looking for. All right, and then they also have the value of r here, right? The correlation coefficient, 0.927. But I want r squared, the coefficient of determination. So yeah, so that's a very easy way to have the calculator do that for you. Just again, you got to make sure that those diagnostics are on. And then let's take a look at the best fit line. Let me go y equals, hit the variables button, go to stats, number 5, over to equations, and then put in the regression equation and graph. And look at that best fit line. That looks like it's a pretty reasonable model. And again, the value of r squared is above 80%. It's 86%, 0.86. Again, telling me that 86% of the variation in y coordinates in these 5 points can be explained by this regression. All right, so it seems like it's, and again, looking at the scatter plot, putting those two together, looks like this is a pretty decent model for this data. All right, so let me actually check the result. All right, submit. Hooray! And again, they gave you all the information you needed to just punch it in a formula right now. All right. All right, so hopefully watching me go over this, looking at the more instruction when you need to, reading the answer explanations when they come up. I'm hoping all this stuff helps you when you work on this material on your own. And thank you for watching.